Next, I'm going to show you how to create some basic logic to control a Boolean writable point. In this case, a point that's controlling an exhaust fan that turns on and off. To create this logic, we need to have some type of algorithm or spec or sequence of operations to understand what we're trying to achieve before we can write the logic. In this case, we're going to say that we have a temperature sensor called space temp in a space, and that space temp is going to be compared to a set point. And if it goes above the set point, we're going to turn the exhaust fan on. If it goes below the set point, we're going to turn the exhaust fan off. It's a good practice to take any type of sensor input and pass it through a numeric writable point before adding it to the control logic. So we're going to begin by creating a numeric writable for our space temp input. One of the easiest ways to create a numeric writable is to right-click on any location in the station, in this case the wire sheet of our cafe folder, and from the new menu select numeric writable. I have the opportunity to change the name of the object. I'm going to call this my space temp, and I will click OK. And here's my new numeric writable object. I can click on that with my mouse and drag it around the page. Once it's selected, I can resize the block so I can read all of the properties. Notice that just like with a Boolean writable, the default properties or slots that you can see on a numeric writable include the out slot, which contains the present value, the status, and the command priority of the object, and inputs 10 and 16. I can set a default value for this numeric writable point by right-clicking on the block, and from the actions menu, choosing the set action. The set action allows me to write a default value. In this case, 72 degrees. With numeric writables, I can add more information to the out slot. I'll double-click on this space temp object and reveal the default view of a numeric writable, which happens to be something called the AX property sheet view. You'll notice that my set action wrote the value of 72 to the fallback property, which is the default value of this point. To add units, I can click the double arrow in the facets field, and in the unit facet, I can click in the value field to change the units. When I do, I get a pop-up menu, and the left pop-up menu is the type of engineering unit I want to use. In this case, I'm going to scroll through the list to find temperature. The right pop-up menu is the actual unit to use. In this case, because I'm writing this in the United States, I'm going to use Fahrenheit as my unit of measurement. But one of the neat features of the facets is if something is in one set of units, a value is 72 degrees Fahrenheit, and you want to render it in degrees Celsius, all you have to do is change the facets, and the system will automatically do the conversion of units for you. Another property of the facets is the precision, which is how many decimal places I want to display for this numeric object. In this case, 1 decimal place for space temperature is fine, so I'll leave it at the default of 1. I also have the ability to put in a minimum and maximum value. The defaults are minimum, infinity, and maximum infinity. I will save my changes, and I'm going to go back to my cafe wire sheet. The easiest way to do this is to go up to my toolbar and use the back browser arrow to take me back to the last location that I was working prior to the AX property sheet view of the space temp, which in this case is the cafe wire sheet. Now I need to create another numeric writable object for my space temp. That's easy enough to do from here. I can right-click on the space temp object and select duplicate. In this case, I'm going to make this my temp SP, which is short for my temperature set point. It's the temperature that we're going to measure the space temp against. And if I want to change that value, I can right-click on the temp SP, go to Actions, and set the value. And let's say we want the set point to be 76 degrees Fahrenheit. So now I have a space temp. In the future, I'll tie this to a physical input value. I've got a temp set point, which allows me to set the threshold for when the fan turns on and off. I need a way to compare the two of them and use it to control this exhaust fan output. And the way I do that is with an object called a TStat. That's an object that can be found in the Kit Control palette. If I scroll down in the Kit Control palette to a folder labeled HVAC, I can expand that HVAC folder, and one of the objects contained in there is called a TStat object. I'm going to drag that out of the palette and drop it onto my wire sheet. Now there's no need to rename it. I'll just leave it the default name TStat and click OK. And what I need to do is I need to bring the values of the space temp and the temp set point, or temp SP, in as inputs to the TStat object and tie the TStat object output to the exhaust fan to control it. The second part of that is much easier than the first. I can take the out of the TStat and with my mouse, hold my mouse over the right side of the out slot of the TStat, click the mouse button, and then drag the mouse over to one of the inputs. In this case, I'll use input 10. And when the cursor changes from a hand to an arrow, I let the mouse button go and it draws a connector. What that tells me is that the out of the TStat is going to write to input 10 of the exhaust fan. Now I need to bring the out of the space temp and the out of the temp SP as inputs into the TStat object. However, I don't see any inputs on the TStat block available for me to bring the space temp and temp SP values into. And so what I must do is right-click on the TStat object, and from the pop-up menu, select the option called Pin Slots. And what that allows me to do is to expose different properties or slots of the TStat object to the wire sheet. And the two properties I want to expose are the CV and the SP. CV stands for controlled variable, it's my input value. SP stands for set point, it's my threshold. So I click OK and it adds those two properties or slots to the TStat object. And now I can take the output of the space temp and drag that to the CV of the TStat. And you'll notice how the value of the out slot of the space temp is passed over to the TStat CV property. I'll take the out of the temp SP and drag that over to the SP property of the TStat. And you will notice the output of the TStat currently is false. What that means is that my space temp is lower than my set point. 72 degrees is less than 76. As a result, the output is false. Let's change that value. If I right-click on the space temp and temporarily change the default setting to 78 degrees, watch what happens to my control. Because the controlled variable, or the space temp, is now higher than the set point, the TStat outputs a true value, which turns on my exhaust fan and which the sequence is calling for. So I know that this is working the way it's supposed to. If I double click on the TStat object, I can see there are a couple of properties I may want to modify in order for this to work properly. If I wanted the exhaust fan to turn on when the temperature was below the set point, I could change the action from direct to reverse, which would change when the TStat would output a true value. A direct acting TStat outputs a true value when the input is greater than the set point. A reverse acting TStat outputs a true value when the CV is less than the set point. The other feature I might want to take advantage of here is something called the diff, or differential. This allows me to enter a deadband value, so that when the temperature is satisfied, I'll neither turn the fan on or off, but leave it in its previous commanded condition. To do that, I click the little double arrow next to the diff field, and I can uncheck the null box. If I enter a diff of 4, that means my deadband will be 2 degrees above my set point and 2 degrees below my set point. I'm going to couple this control with a change in the setting for null on in control to false. Meaning, if I'm in my deadband, I don't want to write a null value to my output. I want to maintain whatever the previous control command was. If I go back to my cafe wire sheet, now we'll see my TStat is outputting a true value. It's keeping that exhaust fan on, and will do so even if we go below the set point, as long as we are in our deadband range. If I right click on the space temp and change the default value of the space temp to 75, the fan stays on. The TStat command continues to be true because I'm within that 4-degree differential that I set. The fan will turn off if the space temp goes below 74 degrees Fahrenheit. So now we've created some basic control logic to control an exhaust fan by comparing a space temperature to a temperature set point.